Hi, everyone, and welcome to today's webinar, Empower Your Developers and Drive Productivity by Leveraging Kubernetes. My name is Carmen Puccio, and I'm a Principal Solutions Architect here at AWS, and I'll be your speaker and moderator for today's webinar. I'd also like to introduce Michael Gerstenhaber, Director of Product from Datadog, and John Motor, Senior Principal Engineer from Zendesk. So to kick it off, I'd like to talk a little bit about modern application development. And when we talk about modern application development, we're essentially talking about what we call the new normal, meaning more and more companies are increasingly global and products are completely digital. Cloud, mobile, big data, and social technologies have impacted application development, but digital disruptions are forcing change even faster. So this new normal means that application leaders really need to instill a new culture into their organization, processes, technologies, things to transform into top performing organizations. And with that said, they have this need for rapid innovation. And to be competitive, they need to innovate as rapidly as possible. So when it comes to innovation and when it comes to going as fast as possible and comes to staying competitive, we talk about modernization. So these days, modernizing your business applications, it's an inevitable part of doing business. Businesses want to drive growth, accelerate migrations with repeatable processes and patterns while maximizing the value as they modernize their applications. Because at the end of the day, it's really about speed and agility for those digital businesses. So the faster that they collect and analyze feedback, the quicker that they react to their customers, the more that they can reduce their costs, the more they can experiment on new ideas, the faster they get those ideas to market, the more successful they are. And so, you know, what you're asking yourself, what does it look like in real life, and what are the options to modernize an application? And containers are a great example of how you can leverage something to modernize your application, right? So we've been talking about containers for a while now, and they essentially accelerate the application delivery while reducing costs. And very common approach is to use containers, right? So the container story is especially compelling because it allows customers to be more effective and more agile. They give that option to deliver applications more quickly for the development and operations teams who are under pressure to adapt to, you know, the growing business needs. So businesses know that getting software products and services to market faster translates into gain market share. Using containers can help enterprises modernize legacy applications and create net new cloud native applications that are both scalable and agile. Container frameworks such as Docker provide that standardized way to package applications, including the code, the runtime, the libraries, and in order to run them across the entire software development lifecycle, regardless of the environment. So what are the benefits of containers, right? We've been talking about them for a while. The first thing is defined as code. So containers package your code with the configuration files and all the dependencies that it needs to consistently run in any environment. It also allows you to take advantages of microservices. So containers provide process isolation. It makes it very easy to break apart and run applications as independent components. Modern applications that are shifting to cloud native and microservice architectures are using containers, and this is the perfect way to encapsulate these various different pieces into little portable units. Automated testing and development. Methodologies are changing, with developers essentially shifting to agile methods, and DevOps and leveraging continuous integration and continuous deployment systems, or CI/CD. Containers being lightweight and portable make great vessels to wrap code up with, you know, in order to push them through these new software pipelines. When it comes to monitoring, containers provide process level isolation, like I said before, and it lets you granularly set CPU and memory for better use of your compute resources. But also with that said, it's very, very important to think about your application level monitoring and how you ensure the overall health of your application as your containers are spinning up and down in a dynamic environment. And last but not least, security and compliance. Because containers help enforce an infrastructure as code mindset into the application lifecycle, a benefit is at the security level. So you have this ability to set and version not just the container itself, but also all of the packages that make up your application. Combine this with the processes, like maybe a vulnerability scan of container images, and incorporate an automated checks into your CI/CD workflow. Your security teams and your developers can now work hand in hand to make sure that there's a high level of security for containerized applications. So when it comes to Amazon Container Services or container services on AWS, since 2014, we've launched more than 50 new features and services to help make running containers easier for developers, right? So our mission is to make AWS the best place to build and run modern applications. And our goal is to remove the undifferentiated heavy lifting that your teams have to do to get new ideas off the ground and out the door, as well as making it easy to optimize your existing applications. So our customers love AWS Container Services because it not only provides the broadest set of capabilities for them to manage their containerized applications, but it's also the easiest place for them to run containers. Our services are deeply integrated with various different services in the AWS cloud. So you get all of the benefits of things like IAM and VPC networking, load balancing, while enabling your DevOps workflow essentially through the various different developer tool chains. So when it comes to having the right foundation for your application lifecycle, I like to do the monolith microservices comparison. But it's really a story about how microservices help you build and deploy faster because you're not running in that tightly coupled single service like you would be in a monolithic application. And people talk about how the cloud enables you to fail fast and quickly learn from your mistakes as you experiment. And if you think about it, the easiest kind of innovation is to drive lots of incremental change via experiments. And that's much easier to do than to wait for one massive change because you can get more iterations and you can learn faster. And this is where the microservices approach really plays well. So you can iterate on each one of those microservices at whatever pace of innovation you want to drive per each microservice. So you can have teams that are staffed appropriately for the work that you want to do. A microservices approach is really defined by how you can have an organization that can make decisions very rapidly and have that technical infrastructure and a set of technical design patterns that really support your ideas behind it, right? So when it comes to monitoring, this is something where I always talk about it with our customers, regardless if it's a container or not. Like monitoring is always very important to optimize the end user experience. So when you think about it, it's an important part of reliability, availability, and the performance of your application. And you need to think about should you collect monitoring data from all parts of your application so that you can easily debug a multi-point failure if one occurs. But before you even start that, you have to kind of answer the questions and think about it, as you're planning this out. Like, what are your monitoring goals? What resources are you going to monitor? How often are you going to monitor those resources? What tools will you use? Who's going to perform the tasks? And who should get notified if something goes wrong? And when it comes to CI/CD, which stands again for continuous integration and continuous deployment, the customers that are modernizing their applications, they see tremendous value when incorporating CI/CD and DevOps practices into the application lifecycle. So by incorporating automation and that cultural component of learning how to integrate frequently and learn from your mistakes, as I said before, customers are able to find and address bugs quicker, improve software quality, and reduce the time that it takes to validate and release new software updates. And lastly, when it comes to security across the entire application lifecycle, you really want to think about how you can secure your application, but you want to think about how you can incorporate automation and detection through the deployment process to address those blind spots without slowing down that pace of innovation. So again, your security teams, your operational teams, and your developers need to work together to realize goals that are essentially around things like, how am I going to embed the security knowledge into those DevOps teams so they can secure the pipelines and so they can design and automate. And then at the same time, they need to learn how to embed application development knowledge and automate, and what are all the automated tools and processes from the security team so they can provide security at scale in the cloud. Because at the end of the day, it's really about making sure and validating that each step of the application, meaning each step of the solution, work only as intended. And again, you're trying to limit that blast radius and essentially contain that environment. So with that said, I don't want to take up too much time. I want to kick it over to Michael from Datadog and let him talk about monitoring Amazon EKS and AWS Fargate with Datadog.
Thanks so much. My name is Michael Gerstenhaber. I'm the Director of Product at Datadog. There we go. Datadog is a SaaS-based product that offers infrastructure, application performance, and log aggregation in a single pane of glass. We're collecting tens of trillions of metrics, traces, and log events from our customers around the world. You might know us from our extensive integrations with more than 250 technologies that we cover out of the box. And you might not be using all of these technologies, but we're there to support you whatever off-the-shelf technology you use. And we're proud to be launch partners with two of Amazon's recent exciting new features, EKS and Fargate. In Fargate, we find an elegant way to further address the issue of elasticity. With EKS and Kubernetes, we tap into an open standard with a vibrant and sophisticated community that is moving with incredible velocity. In either case, though, we're all monitoring the applications running on these platforms or inside these containers, which is what I want to emphasize. Taking advantage of application auto-discovery, Datadog can tell you how your applications are behaving based on these ECS, Kubernetes, or Docker constructs, as well as ingest your own custom telemetry. We're all here because we're either evaluating containers and orchestration or have already adopted this technology, and we're not alone. But it's not just that more and more organizations are adopting. We also find that adopters are ramping up fast. When you add orchestration into the mix, the numbers look even more aggressive. I'd like to emphasize what monitoring means to orchestrated applications. We've seen orchestration usage skyrocket in the last year and a half. And with that, we've been able to learn from the experience of our customers as they adopted this technology and spoke to us about their needs. In our studies, we see that the median lifetime of a container is 2.5 days versus 25 days. And that's for Docker containers. On ECS and EKS, orchestration shortens that significantly, and also shortens the lifespan of hosts by 40% as well. Though to a greater degree than ever, our services are abstracted away from the resources that they rely on. With more moving parts underneath the hood, the greater the need is for observability. Our customers are running tens of clusters with tens of thousands of hosts, hundreds of thousands of containers, and because of the churn in those containers, they're seeing millions of containers per day. While both Fargate and EKS fulfill the promise of containerized workloads, each introduces their own complexities. We don't want to get bogged down in these concepts, but we do want to use them when we need to drill down. Whether it's pods and deployments or tasks and families, we're running the same applications and services that support our customers, and this is where our focus lies. And in order to automate, we must be able to observe. Operational complexity increases with the number of things to measure and the velocity of change. As you saw both in Cameron's and my slides, with orchestrated environments and CI/CD tools, both of these factors are moving up and to the right. Everybody knows for yourself what downtime costs. The average median-sized company loses $100,000 for every hour of downtime they see. For larger orgs, the average is more on the order of $500,000, and that's just strictly revenue. That doesn't account for the engineering effort of remediation or negative Twitter mentions or whatever you're tracking. So start collecting metrics in staging and local environments long before moving to production, so you know what to expect when you launch. You already know before any move to microservices or before any move to containerization, what metrics matter to the performance of your component. And we know what metrics we can use to troubleshoot problems when the performance of those components degrade. So now we can use new constructs. You can ask questions like, where is my container running? Some workloads run better on differently optimized virtual machines. Services can be affected if all the containers on US West lose connectivity. Capacity is a fundamental factor in saturation, and Kubernetes and ECS come with their own constructs and rules. Tags are key to modern monitoring because they allow you to aggregate metrics across your entire infrastructure at whatever level you choose. You can slice and dice in any dimension. And because of that, we can ask similar questions in new ways of new abstractions. We can look at pods or daemon sets or deployments or services. We can answer these questions, whether we get the information from the pseudo files that describe the containers themselves, or from the Kubernetes or Amazon APIs, and then stitch them all together into a single pane of glass for observability. I'd like to introduce John Motor. It's been a pleasure working with him for many years. He's with Zendesk, who are one of our earliest customers. And it's especially fun in this context because we rely on Zendesk for our own needs, and we couldn't communicate and maintain our customer base the way we do without them. So having watched their move into Kubernetes, into orchestration, it gives me great pleasure to be able to introduce, John Motor. Thank you.
Hi there. My name is John Motor. I'm a senior principal engineer at Zendesk. I work on infrastructure, platform, and Kubernetes, and I've been at Zendesk for a little over 4 years now. So today I plan to be talking about how Zendesk has been using Kubernetes, AWS, and Datadog over the past few years that I've been involved. So brief bit about Zendesk. Zendesk is also a SaaS company. We build customer service and engagement solutions to help businesses provide the best customer experiences. We were founded in 2007. We're located in San Francisco with about 2,500 employees worldwide, and that includes over 500 engineers. We have 16 offices scattered around the world. And we have over 130,000 customers in over 160 countries that use our solutions to help their customers in over 60 languages. Here's a few of our customers that we're proud to work with. As you can see, our customer base represents a range of industries, from software to manufacturing to healthcare to government organizations. So I'm going to talk about the Zendesk stack for a little while. For the first 5 or so years of Zendesk, we were a traditional 3-tier Rails app. We had a Rails monolith fronted by Nginx. We used MySQL as the primary database, and we were located in co-located data centers in multiple regions. We had a whole bunch of servers that were managed by our team, racked and stack, and we used Chef to configure all those servers. For the first large chunk of Zendesk existence, we didn't use the cloud for any production stuff. It was co-located data centers only. So, and devs worked mainly on the Ruby on Rails code, and we had a centralized ops organization to handle the production environment, servers, Chef configuration, networking, etc. But over time, the Zendesk grew. Both architecturally, the amount of data and the number of engineers grew. So we found that a Rails monolith was no longer sufficient for our needs. It became really painful because every time any change needed to happen, we'd have to deploy the entire monolith, which was risky, slow, and painful. So we started moving in the direction of microservices. Some of those were also Ruby or Ruby on Rails apps. We started branching out more, some Node.js and Scala and Golang. We also expanded the number of data stores we're using, so introduced more Redis and Cassandra, and later Kafka, and a broader set of technologies involved. So that was great in a lot of ways. We were no longer limited to a monolith with a single stack, so we could solve problems correctly, but it started putting a huge burden on our operations organization. The number of Chef cookbooks we used to manage all these servers exploded. The number of bespoke host groups and Snowflake started getting larger and larger. And we also started expanding out to more data centers. So the number of servers that had to be managed got increased and increased. So we got to the point where developers at Zendesk were excited about and wanted to deploy new microservices, didn't want to keep stuffing more logic into our old Rails monolith, but it was really difficult. Sometimes they would come up with an idea for a service, but they would have to talk to the ops organization, and due to their backlog, it would take weeks or months to provision the servers and configure them and get them ready to go. So this was not sustainable. So around 2014, 2015, both the dev team and the ops team got together, took stock of where we're at, and asked, what are we trying to do? And our main goal was to empower the engineers. We have, as the functionality of Zendesk expanded and got more broad, teams became the subject matter experts on the particular domain knowledge of their area, whether that happens to be tickets or real-time messaging, or chat or voice chat. We wanted them to be empowered to make decisions that made sense for their domains. And that way they could move at their own cadence rather than being needed to go work in lockstep with the ops organization. And we wanted to move to more of like a DevOps model. So rather than having a centralized ops organization, we push both the responsibility and the skills and ability out to the edges. While at the same time, it was really important for us to find a way that these teams could follow the best practices around security, around compliance, around scalability. We didn't want every team to need to become experts on all these specific domains, but still take advantage of a lot of the knowledge we've gotten over time. So around the same, so we talked about that, and the solution, or part of the solution to get points in that direction, was we wanted to start containerizing services with Docker. So this is again around 2014, 2015. Docker was the new hotness on the scene, and we found it was a really good match for the problems we had. So this way the devs could control the runtime and the libraries and Ruby versions. That became in their hands rather than relying on operations org to configure every server. We could also had advantages like being able to, with Docker images, have the exact same code running on my laptop or a test environment or a production environment. So not fewer issues of, well, it worked on my machine, but not out there. So, and also it had the promise of radically cutting down on the number of bespoke Snowflake host groups we had running around. If we could standardize on a single set of servers that are just running Docker, that simplifies a lot of the operational load. But so that sounded great. We're all excited about that. But then the question became, all right, how are we going to run these Docker containers in our shared production environments? So at the time, Kubernetes was just come out. I think Kubernetes 1.0 came out in July 2015, which is right around when we're having a lot of these conversations. So at the time, Kubernetes and Mesos were kind of the two front runners as far as container orchestration, with Docker doing some stuff with Docker Swarm. But even in the early days, the sense we got was that the design of Kubernetes was really well done. It had a API-driven declarative model. It had mechanisms for self-healing. And just as I read through the design docs and looked at the examples and the code, the sense I got was that this is a system that was designed by people who have a lot of domain experience, who've thought through a lot of the edge cases and problems that, it takes 10 years of expert knowledge to really understand. So we decided to adopt Kubernetes as orchestration platform. Great. So then we started the build out. Back in this time, around 2015, 2016, a lot of the great open source and managed services didn't exist yet. Amazon had not come out with EKS. There wasn't COPS. There wasn't, like these days, you can look online and go to the Kubernetes documentation page, and there's a huge list of open source and paid services and managed services that allows you to run Kubernetes in a reliable, scalable way. But those weren't really around at the time. So we spent a lot of time both understanding Kubernetes deeply. It was important to us for this to be a reliable system, that we didn't just like spin it up on some servers and start deploying stuff and call it a day. So we needed to really understand it and make sure that it was highly available and secure and followed best practices around compliance and all these things. At the same time, since we were building a new platform, we also took the opportunity to rethink a lot of the ways that we manage things. So we also made a shift to, rather than having a bunch of servers that were managed by Chef that were constantly updating themselves, we made a shift to more of an immutable infrastructure model, where we would create instances, and if we wanted to make changes to the EC2 instances, we would destroy them and create new ones. So there were several architectural and best practices things we decided to make and move at the right time, so we weren't building a new system on the mistakes that we had made previously. Which on the whole was really successful, but it took a long time to get to the point that we were really confident and ready to run stuff on. So, so that's 2016, 2017. Where we're at now, 2018, 2019, we've got 25 active clusters running, which is over 100 distinct services running on those clusters, which is about 2/3 of all of Zendesk. I'm going to talk briefly about that transition period. What we did was we started off with a couple of small test projects, like non-production stuff, nothing to test customer data. Started running those, that went well. And then what we ended up doing is we had amongst our engineering teams, a subset of them were really enthusiastic early adopters who just immediately jumped on the bandwagon and said, yes, we want to run our stuff on Kubernetes. So we have those teams migrate their apps from the existing infrastructure into the Kubernetes infrastructure. From there, that went well. From there, we kind of found the next wave of people, and pretty much all the new services that we built at Zendesk were beyond to Kubernetes. And then over time, you can see we're still at only 2/3 of services, because migrating a lot of the legacy apps has taken a while. Remember that Rails monolith that I mentioned way back in the day? we're just starting to run that on Kubernetes because it's a large thing that has a lot of dependencies, just a lot of cruft there. So it makes it both risky and challenging to move that on to an entirely new platform. But we're getting there, and I think pretty much every engineer at Zendesk I've talked to has no interest in going back to the way we did these things. So let's talk a little bit about the benefits. Major benefit, developer velocity. I said previously that it would sometimes take weeks or months to get a new service running in production. Now it can happen in days. So honestly, I've managed to make a couple of test steps that within, like, in the morning I would create that, and by like the end of day it was running in our shared clusters. So the ability for developers to experiment and try things out is way better than previously. We're actually working on a project right now to make it so easy that a new developer starting at Zendesk on day one of their training could deploy a hello world style application to production so they understand the entire workflow. And as a result of this, our engineers spend way less time previously than just waiting on other people to do stuff. I'm an engineer, so I find that when I want to build something, but it's blocked by, okay, I need to file a ticket, wait for someone to get back to me, like that whole process just completely throws off my flow and frustrates me a lot. So really happy that the developers are able to get more done. Another major benefit is that the developer teams are empowered to tune and tweak the services they make. Again, previously when we had a centralized ops organization, if a team wanted to increase the RAM or CPU of the host group they're running on, again, it was create a ticket, look for hardware. Do we have enough hardware? Upscale things. It was a large process. Now, since in Kubernetes you can, through its API, request each pod has a certain CPU and RAM, it's entirely in the developer's ability to increase or decrease CPU or RAM or replicas. You can scale up and scale down. So as a result, it's really each individual developer team, the people who know their code best and are closest to the real problems, who become the operators of their own service, which is great. But the side effect of that is now developers need tools to operate their service. We can't expect developers to be responsible for and able to handle that if they don't know what's going on with them. If a developer team, if we say, well, okay, you run that, but they have no idea if they're overloaded, then we put them in a bind. So what we need to do is good enough tooling so that they can monitor the response time or error rates of their applications, and also let them know if something's going wrong. We want all of the pages and any alerts to be going to the team that owns the service, rather than a centralized on-call team that has to figure out what's going on. We need dashboards for them to be able to look at their metrics over time, figure out whether if they push some new code, did that cause a regression in performance or something like that. We also need some interactive UI so they can, if they see a problem, figure out what's going on. Let's dig in. Is it this problem? Like, is there a correlation between response time and memory consumption? Is there something else going on? And that is where we find that the integration between Datadog and Kubernetes and AWS has been awesome for us. Because so what we do is at each of our Kubernetes clusters, actually in every host, our entire infrastructure, we install the Datadog agent. So just out of the box, no configuration necessary, it immediately starts pulling information about the containers, about the hosts, networking, all sorts of things, and feeds that into Datadog, a central repository for all the information. They have a great container UI, which allows us to pulls in the labels and tags from the Kubernetes objects, and is a nice interactive UI, so you can see what the relative resource utilization of each one. We can create standard dashboards and monitors out of the box for each team, so they don't need to reinvent the wheel. It's taken those of us who've been working on this for a while realize that, okay, knowing what the most important signals to watch out for takes time and knowledge. So rather than, again, requiring every team to reinvent the wheel, we can give a bunch of best practices that they can just follow. And there's a mechanism to create custom metrics. So if teams want to have create metrics based on information that's very specific to their application, you can easily push metrics through Datadog's statsd interface. Or they can instrument their code using Datadog's APM to get distributed tracing and more information about how requests are being handled by multiple services in the infrastructure. So as a result, having consistent metrics and tags is really huge, especially because sometimes a service will stop working in the middle of the night, and the team that's responsible for it might be asleep. So it's really handy if whoever is the first responder looking at an issue, it's predictable where they can find information about that, what the logs look like, where they can find monitors. At the degree of scale we're at, where I would say one of the major transitions that's occurred is that Zendesk is past the point where even the smartest engineers can hold in their brain how all the pieces fit together. Maybe like 7 or 8 years ago, someone who really knew the system could see an error and say, okay, there's an error on this particular one. That must mean like over here in the database, that's the problem. We've scaled past that. There's no one has the, you can have a broad, shallow view or a narrow, deep view on something, but you can't know everything. It's just impossible. So therefore, having a degree of like consistency and standardization across all these services make it possible to track down problems if and when they occur. So briefly, looking forward a little bit, here are some of the interesting things we're working on right now. Concurrent with the move to Kubernetes, we've also had a major move out of our data centers and in AWS. When I first joined Zendesk 4 years ago, we were using AWS, but only for our test environments. We didn't want to run any production workloads on AWS. But maybe about 3 or 4 years ago, we took a look at what AWS's offerings were and decided their capabilities matched our needs. So we started moving stuff into AWS, and we're actually at the point where almost entirely migrated our production workloads in AWS now. Which is fantastic. It gives us way more abilities to scale. The managed data stores are fantastic. So one of the things that we are working on doing is making it just as easy for developers to automate the creation management of the data stores through the APIs AWS offers us, as it is for them to deploy stateless applications to Kubernetes. That's kind of the next phase of self-service and developer empowerment that we're aiming for. We're also, the team I'm working on is also working on trying to improve the abstractions and plumbing for dev teams. There's a lot of moving parts when you're taking a look at AWS and Kubernetes and networking and security groups and load balancers. And I don't want to expect every dev team at Zendesk to become experts in all these technologies. I want them to be focused on whatever the domain area they're supposed to be focusing on, and let a lot of this platform stuff be handled by my team. So we're trying to come up with what are useful abstractions that can hide a lot of the complexity there, but still allow developers to get the work they need done. And the other major thing I'm excited about these days is looking into service mesh technologies. I think I have a hunch that the improvements and the capabilities unlocked by a move to Kubernetes, a similar jump in capabilities will be made possible by the network controls we have via service mesh of some sort. There's AWS's App Mesh, there's the Istio open source project, so we're investigating and looking to a lot of those. So that is an overview of what I've been doing. If you're interested in working on all this, I'll make a quick shout out that Zendesk is hiring. We love people who are interested in infrastructure, distributed systems, Kubernetes, all this stuff. So go to zendesk.com/careers, I think. And then with that, I'll hand it back over.
All right, awesome. So thank you, Michael and John. We're going to transition into our live Q&A. Just as a reminder, you'll be able to submit any written questions through the questions panel. And in the event that we aren't able to get to your questions today, we will follow up with everyone individually via email. So the first question that I do see in here is for you, John, and it's essentially around CI/CD, and at the same time a little bit about your AWS implementation, a little bit more detail. You talked about some really cool things about like that POC that you were building, where essentially a new developer could come in and deploy an application into production, just to get an understanding of all of the pipeline, if you will, or the tools in place. And I think it's fantastic that you're basically saying you don't want the development teams to be experts in all of the technology. They just want to be able to get their work done. I think that's a great initiative. So the questions around your CI/CD. So like, what are you guys using for CI/CD? And then are you deploying to EKS? Are you deploying to Kubernetes on EC2, maybe via COPS? Like what's the model look like?
For CI/CD, we are we have an automated build pipeline for building Docker images. So every time we use GitHub for source control. So we have a pipeline so that every time a merge to master, generally for a branch is created, a Docker image is created, pushed to a registry, and tagged. And then we actually have an in-house open source project called Samson. You can find github.com/Zendesk/Samson, which is it's the deployment tool that we've been using for several years now. For a long time, it was a glorified wrapper around calling like bundle exec cap deploy. But we've enhanced that to also interact with our Kubernetes clusters, so that from a deployment perspective, a developer logs into Samson, chooses their project, and chooses which staging or production clusters they wanted to push their app out to. And it handles a lot of the handling the authentication, handling secrets, and configuration overrides, and that sort of thing. So that's the current implementation on how devs do that. As far as what we're running on at the moment, originally we built all of our Kubernetes clusters using some bespoke tooling that we created ourselves, using a combination of Chef and CloudFormation. We're actually been transitioning over to using kops. We looked at EKS, but when we started the transition to using our tooling over, it was about 6 to 9 months ago, and EKS was not yet available in all the regions that we needed. So for the moment, we are building everything on kops, but we're probably going to revisit EKS in 6 to 9 months' time and see where we're at.
Awesome, cool. The other question is for you, Michael, and it's essentially like, if you could kind of at a high level talk about the Datadog tool as a whole compared to the Kubernetes dashboard. Like, is there a line in the sand? And obviously, like, you have a lot more application insight, so maybe you want to talk about the application perspective and the logs that come from your containers and stuff like that.
Yeah, thank you. That's exactly it. We're a multi-source observability tool. So if you're using Nginx or Redis or any other of our many more than 250 off-the-shelf integrations, we will expose metrics about those components with Kubernetes constructs. So you can see, how your Nginx pods are behaving. You will also see application performance monitoring and your logs from your application and from Kubernetes directly in this same tool, allowing you to reduce your mean time to repair by pivoting between your metrics that are telling you that something is going wrong and your logs and application performance monitoring, which tell you why it's going wrong. I could also defer to John a little bit here, as he uses Datadog every day to monitor Kubernetes as well.
Yeah, I think the Kubernetes dashboard is fine for letting you know what's running in a cluster. It's designed as a you have a dashboard running in a cluster, so you can see the workloads, deployments, pods, et cetera, et cetera. But like I said, we've got 25 clusters, so we don't want to be jumping in between 25 instances of Kube dashboard to look at it, and these clusters are spread all over the world. So one huge benefit is that just the aggregation of information that Datadog gives you. It also, I would say I would liken Datadog's functionality more towards Prometheus, insofar as you could. Prometheus is an open source. You can collect metrics, you can create alerts, that sort of thing. But you're responsible for the care and feeding of those Prometheus instances. Datadog basically says it's a SaaS offering, so we'll handle all that for you. We'll aggregate your metrics. You can create monitors and alerts, that sort of thing. So it's to me, it's like pointing out how things are running and what's working and what's not working, rather than just what is running.
Cool. We have another question for Michael and Datadog. So what does it look like in the OpenShift space, right? And you guys have any integration from the OpenShift perspective?
Sure, we actually have quite a few customers monitoring OpenShift with Datadog, and this is similar to my last answer. We do monitor OpenShift natively and through all the Kubernetes components, but we also monitor your applications running on OpenShift. So this is largely the same answer, except to mention that we do have a special integration for OpenShift and other PaaS tools as well.
Awesome. All right. So
one of the things to note is I find one of the interesting things that we found with Datadog is that different teams require a different view of what's going on. So my team is responsible for the running and the managing of the Kubernetes clusters. So we're mostly interested in issues of like cluster capacity and networking and resource utilization, that sort of thing. Whether any particular app or service running on the clusters is functioning or throwing errors and that sort of thing isn't really our concern. That is the responsibility of the dev team. So they're really interested in like error rates and response times of their particular applications. So in a way, we need like different views where my team stays at kind of very high level and looks at overall cluster behavior, and the individual dev teams need to zero in on their service or services. So having the ability to create multiple views of the same set of information is really important.
Awesome. So with that said, there's no other questions in there. So I just want to start the wrap up process. So again, Michael and John, thank you so much for taking the time. I really do appreciate it. So to the folks listening in, we want to thank you all very much for attending. If you do have any more questions, please don't hesitate to reach out. Thank you again to Michael and Datadog. Thank you again to John and Zendesk. And thank you to all for listening. Have a good one.